right, this is art and math. So this is the last portion of the class, and we're going to talk about what Dali and nuclear mysticism is. And I'm going to go ahead and get started. So first of all, mathematics is highly related to art. If you look at symmetry, structure, shape, and beauty, all can be described using mathematics. So we're going to look at some of the topics in math and how Dali utilized them in his artwork. So the key concepts that we're going to talk about is nuclear mysticism. What is that? Basically, it's a manifesto that Dali created that said, I am no longer a surrealist, I'm now a nuclear mysticist. And then we're going to talk about the golden ratio, Fibonacci sequence, and pi, and also the fourth dimension. By the way, when I'm recording this is Pi Day, so happy Pi Day, people. I know we didn't get to see each other in class because it's spring break, but happy belated Pi Day. So the first thing we're going to talk about here is how did Dali get inspired to use mathematics in his art? So I think it's very important to talk about the atomic age and then also nuclear mysticism before we actually see examples of Dali utilizing math in his art. So Dali's math interests, that and science, basically started in a long time ago, actually, when he was a child, but it really materialized in 1945. So if you guys are familiar with World War II history, 1945 is the year in which the bomb was dropped on Hiroshima and Nagasaki. So anyways, that basically ended the war with this new use of this atomic, energy. After people saw what happened, a lot of people had disdain for atomic research. Dali remained neutral because he thought nuclear power could be used for good, not just used for bad. So Dali starts incorporating the idea behind atomic research in his artwork. So we're going to see some things that basically relate back to the bomb dropping or in general atomic stuff. And he also feels like it's necessary in order for his art to be cutting edge for him to utilize this stuff in his artwork. So for starters, he recognizes Werner Heisenberg as his new father. And he says that, I no longer am following Freud to a T. I'm starting to follow Werner Heisenberg, and in particular, his uncertainty principle. So we're going to talk about the uncertainty principle, and we're going to talk about some other stuff here, but I'll hold off that conversation for a little bit. Dali also shows an interest in particle physics. So he's really interested in how this all is incorporated. Basically, Werner Heisenberg has done some research in particle physics by this time, and Dali is really interested in how this works. So Dali works with his mathematician friend Mattia Gaika, who works with the golden ratio. So this is going to be completely, different than the uncertainty principle. But however, we're going to see there are paintings that incorporate math and the uncertainty principle in it. And finally, Dali's artwork during this time reflects this notion. So what is nuclear mysticism? Like I said before, it's a manifesto that Dali wrote and basically embraces the philosophical ideas behind quantum mysticism and their explanation of consciousness. So if you look at quantum mysticism, basically what is key to that movement is to determine reality versus perceived reality. So what does that mean? So that means if somebody came in the classroom and quickly stole somebody's book off the table and ran out, and if campus security basically asked each person individually what did the person look like that stole the book, we would get probably 20 different accounts of what that person looked like. So the problem is being a human, we have perceptions, and when we view things, that's our perceived view of whatever went down. So that might not be an unbiased review. So I just want you to know that perceived reality is individual, and it is not unbiased. It is not unbiased, is what I'm trying to say. The only unbiased observer would be a camera, and even then, there are some problems with a camera depending on like where it's sitting, how is it being utilized, who is monitoring it, that kind of thing. So there is no true unbiased perceived reality. So mathematics and science prove the existence of God. Now this is totally Reader's Digested here. Dali's manifesto about nuclear mysticism is literally about 3 inches thick, but the core belief system in it, and what Dali is saying over and over again, is through mathematics and science prove that there exists a God. So Dali declares himself the first painter of the atomic age. Okay, so this is key to nuclear mysticism, and that's what it means. So we're mixing the idea of nuclear research of math and science with this idea of religion. So we're going to see in Dali's work that Dali goes back to his mother's Catholic roots, and we will see a lot of pieces have religious imagery in them from this time period. So here is an image of Werner Heisenberg. He is Dali's new father of thought. He came up with the uncertainty principle as stated before. And basically, I'm going to tell you about that in a moment, but he was a German theoretical physicist. He was also the key creator of quantum mechanics. He also, I believe, won an award for his work, and the uncertainty principle has not been disproven even today. So once again, Dali is replacing Freud with Heisenberg, and he's saying the world of physics and its connection to the exterior world transcends Freudian psychology. So he's more interested in the outside perceived reality rather than the interior dreaming mind. So Dali, he starts painting this exterior world rather than focusing on the interior dreaming mind, like I said. So what does the uncertainty principle mean? Once again, this is Reader's Digesting because we could talk about that for hours. And in fact, I think in some physics classes, it takes like a week to really understand. But I'm going to try to have you understand it in a sentence. So at an atomic level, nothing is touching. And those particles can be viewed, and it's either its position or its velocity, but not both simultaneously. So what does that mean? That means if I know where the particle is, I don't know how fast it's going. And if I know how fast the particle is going, I don't know where that particle is. This is, like I said, if you want to go down the rabbit hole, go on YouTube and look up some videos on the uncertainty principle to understand what they're talking about. But this is going to be key to this movement, okay? So we will come back to uncertainty principle in a little bit. So the first topic in terms of math in which Dali used, and it needs to be understood first, is called the golden ratio. So this woman here is wearing a mask that's based off the golden ratio. The golden ratio is a ratio that the ancient Greeks discovered that make things more aesthetically pleasing to the eye. So what a plastic surgeon has done in Hollywood has created like these masks based off of your race and based off of the proportions that make somebody more aesthetically pleasing to the eye. So that's what you see that's on this woman's face. So what's the golden ratio? The ancient Greeks found a mathematical connection to things that are perceived to be beautiful. They utilized this knowledge to create works of art and architecture such as the Parthenon. A lot of statuary from the ancient Greek times utilizes the golden ratio. The golden ratio is also known as phi. There's the symbol on the screen for it in red. And the image of the golden ratio, or the idea of the golden ratio, was lost throughout the Middle Ages in the European nations. However, that is true and untrue. I'd say it was lost in the visual arts, but in architecture, it was going strong. So Gothic architecture will display the golden ratio. Also, something to note, the Middle Eastern and Asian countries still utilize the golden ratio in some of their art. So it wasn't completely lost during the Middle Ages. But, you know, if you look at some of the paintings, you're going to see they are not proportioned well. And the golden ratio is definitely not used in the visual arts. So what has happened is during the Renaissance or the Rebirth, the idea of using phi to convey beauty resurfaced. And it was due basically to people like Raphael, Leonardo da Vinci, Michelangelo, reading ancient Greek texts and really studying the structure of their statues. So they started utilizing it, and that's why we know of most of the things the Renaissance masters have done to be perceived to be beautiful. For instance, the Mona Lisa, done by Leonardo da Vinci, does have the golden ratio in it. So I'll show you how that looks in a little bit. Salvador Dali, he knows about the golden ratio because he went to art school, number one, and he studied art history. But number two, he also decided to utilize it during his nuclear mysticism period. So, what is the golden ratio? If we take a line segment A and B and divide it at a certain point, we have an unknown value, which is a longer half. We're going to let stand with a variable g, and then we're going to have a small area, which we're going to call 1. So if I set up a ratio of small segment to large segment and set it equal to large segment to the total line segment, I get small, which is the value of 1, over large, which is the value of g, equals large, which is the value of g, over total. The total line segment would be g plus 1. So that looks like this. 1 over g equals g over 1 plus g. Now, because of the ratio, I can cross multiply. So if I cross multiply 1 times 1 plus g, I get 1 plus g. If I multiply g times g, I get g squared. This is quadratic. All quadratic equations have to be set equal to 0 to solve. So I get g squared minus g minus 1 equals 0. If I use the quadratic formula on that, because that does not factor, I get 1 plus or minus the square root of 5 over 2 equals g. So I have two answers, 1 plus the square root of 5 over 2 and 1 minus the square root of 5 over 2. That is the golden ratio. So if I put that into my calculator, 1 plus square root of 5 over 2, I get 1.618, and it goes on and on and on forever because it's an irrational number. And if I take 1 minus the square root of 5 over 2, I get 0.618, and it goes on and on forever because it's an irrational number. All right, so I think we're going to stop right there, and I will pick up on these golden polygons for your next video.